Whenever you're ready, Professor Martin.
Thank you very much, Kareem. So good afternoon, everyone. A very warm welcome from Glasgow in Scotland. And I'm just going to speak for a few minutes to introduce myself and to set some context for why I'm here. And then in our remaining time, I will be very happy to answer any questions that you have. So who am I? Well, I'm an astrophysics professor at the University of Glasgow. That's in Scotland in the UK. And my official title is Professor of Gravitational Astrophysics and Cosmology. That sounds very complicated, but what it means is that my research is concerned with understanding our universe and some very fundamental questions about how our universe began and why it looks the way that it does now. And a lot of this is to do with the research of Albert Einstein. He's perhaps one of the most famous physicists who has ever lived. And just over 100 years ago, Albert Einstein published a theory of gravity. And this was a very remarkable achievement. In fact, some people think it's one of the cleverest theories that anyone has ever developed in physics. And it says that gravity is not really a force between massive objects like the Earth and the Moon and the Sun, but instead it's the consequence of the curving of space and time by massive objects. And we think of this sometimes like having a stretch sheet of rubber, like a trampoline. And if you jump on a trampoline, the trampoline will wobble, it will shake, and the presence of massive bodies in the universe, like stars and planets, they cause the fabric of space and time to shake just like that. So this is what I do when I'm engaging in my research as an astrophysics professor. And I'm part of a very large group of scientists across the world called the LIGO Scientific Collaboration. And just about 5 years ago, we discovered for the very first time something that Albert Einstein predicted, something called gravitational waves. These are the shaking, the wobbling of space and time caused by massive objects colliding or exploding in our universe. And such events occur, fortunately, not close to us, very far away in our universe, but they are very difficult to detect. And it took 100 years after Einstein predicted that gravitational waves existed before we could detect them. And that, I am very proud to say, was awarded the Nobel Prize for Physics in 2017. Not to me, but to 3 of my colleagues in the collaboration. But they acknowledged that this was an effort by more than 1,000 scientists to achieve this discovery, to discover gravitational waves and to begin to use them to learn more about our universe. So if you want to find out more about that part of what I do, then there are many good resources you can find. The collaboration that I'm part of, called LIGO, well, you can find out about LIGO on our website. And I'll be happy also to answer any questions that you might have about gravitational waves and how we detect them. But in my final few minutes, let me just say something about how I got here. So now I'm an astrophysics professor, tackling these very challenging questions about the nature of our universe and the nature of space and time. But many years ago, I was just like you. I was studying at high school and trying to think what I wanted to do when I leave school. And I decided to go to Glasgow University, where I now work. As a student, I went there to study physics and astronomy. And these are some of the reasons, I think, why studying physics and astronomy after high school is a useful idea. It does help to understand the world around you. And I think it certainly satisfies my curiosity. I am still very curious to learn more about our universe. And I was when I was in high school as well. And studying physics helped me to develop that curiosity. But it also develops your critical thinking and problem-solving skills. And that means that if you complete a physics and astronomy degree, then you have skills which open a wide range of future careers, not just in fields to do with the fundamentals of our universe, but much more practical applications of physics and astronomy, driving technology, impacting our society and the environment, and of course our economy. So most universities offer physics or astronomy as part of a flexible degree structure, and Glasgow is just like that. So there's a lot of detail on here. I won't waste too much time going through that. You can follow the links. I think you have access to these slides. But the main thing to stress is that you have many options open if you study a subject like physics or maths or astronomy at university. You have many different career paths, and you even have many different paths through your degree before you even complete it. And the Institute of Physics in the UK, I am a member of the Council of the Institute of Physics, and I chair the Education Committee of the Institute of Physics for Scotland. So it's my responsibility to spread the word about how useful physics degrees can be and how many different careers can be opened by studying physics and astronomy. So here is one website where you can find out lots more. And here is another, in fact, 3 separate documents that have been written about the kinds of careers that physicists or also astronomers can pursue after studying these subjects at university. So my department in Glasgow University, I'm pleased to say that we have received many honours for our teaching and our research. In fact, this is me here receiving a medal from the Queen, Queen Elizabeth II, just a few years ago. So there are too many to list them in total, but I think just what they emphasise is that many of our staff and our students are passionate about what they study and about sharing that with others. And we think that anyone who comes to study with us is lining themselves up for a very bright future. So I'm sure you have bright futures ahead, and I'm more than happy in these final few minutes to answer any questions you might have about studying physics and astronomy at university. Thank you.
Okay, thank you, Professor Martin, for that and for the insight on that. Just before we go to our next guest speaker, I'm just going to see if we have any questions at the moment. I'd like to ask you, did you always know that you wanted to go into astrophysics, or, you know, did it slowly unfold?
Excellent question. I wondered about covering that in my slides, actually, because it's a very personal thing. People's journeys are often quite different depending on how they begin. But in my case, yes, the answer is yes. And I had a very helpful teacher in primary school and elementary school who was passionate about studying the stars and got many of us in the class interested in looking through telescopes and so on. In my case, maybe my passion was just a little greater than the others, and it stayed with me throughout my time in school, then through high school and university. But absolutely, I think from the beginning, astronomy was something I was really passionate about.
Interesting to know. And what kind of things do they cover in the first year at university? Do they just dive straight into it, or?
Pretty much. And one thing that I always like to say, to summarize this, is that astronomy really is physics. I mean, that's why, as you referred to it, as astrophysics. Historically, we called it astronomy. In fact, in your part of the world, there is a very rich heritage of studying astronomy long before this was common in Europe. But nowadays, astronomy is more focused on applying our knowledge of physics, but applying it up there instead of down here. So in fact, the syllabus we cover studying astronomy is quite similar to the syllabus you would cover studying physics. You learn about light, you learn about dynamics, that's the way that particles interact with each other through collisions, through changing energy. You learn about materials, the different properties of materials like solids, liquids, gases, and so on. You also learn about how the environments out there in space are so different from the environments down on Earth. So that's where the astronomy lectures are a little bit different from the physics ones, because we are focused on more extreme environments. And you don't get much more extreme than the black holes that collided that caused our detection of gravitational waves. So in the final part of our first year, we just begin to introduce some of those more exotic ideas, but very gently, because the later years of the degree then build on that slowly. So we begin with some fundamentals, building on what people learn in physics in high school, and then we take it from there.
Sounds amazing. Thank you, Professor. We're just going to invite our next guest speaker for a minute, and if you wouldn't mind holding on so we can come back to you with some questions.
Of course.
Thank you. Mr. Amar, are you with us? Hello.
I am.
Thank you for joining us and taking the time.
Absolutely. Can you see me and hear me?
Yes, we can.
Okay, brilliant. I need to share my screen in just a second. Just two quick comments. Professor Martin, thanks for a great presentation. That was great fun. I wish I had all the time in the world to study that sort of thing. I mean, I think the black hole collision and the gravitational waves discovery, it was all over the news. It's a really big step forward in physics. So congratulations to you and the team. Also personally vouching for Glasgow, Edinburgh and Scotland in general as a place to study. And I hope you get some keen physics students from the NES. I'm actually alumni of the school, graduated 13 years ago. I didn't consider studying in Scotland, but maybe if I went back in time knowing what I did now, I'd probably think about it. So thanks again for your time.
Thank you. That's very kind of you. Thank you.
Absolutely. And definitely, again, personally vouching, you know, if there are students on the call who like physics, like maths, and like the stars, it's a great path forward to think about studying physics initially and then maybe specializing later. Sorry, so appreciate I'm going off piste and I have some limited time. Shall I share my screen now?
Yes, please, if you would. Yes, thank you.
Great. And sorry, I can only see University Councillor, but I don't remember meeting you when I was at school. Just so I know your name.
No, I wasn't there. My name is Samar Muraish, and I am the University Councillor. And I'm very pleased to meet you.
Okay.
This was organised by the students, so we'll let them take it.
Brilliant. Yeah, I know Kareem had a part to play. Okay, so you should see the screen. Can you just confirm that? It's I'm afraid there aren't any stars or pretty pictures just yet.
Yeah.
That's why we can see it. Thank you.
Look, good afternoon to everyone. I'm Man. I hope you're all in good health. Most importantly, thanks to Kareem and the NES team for inviting me. And like I said, I can't believe it's been 13 years since I graduated. I just, you know, if there are any teachers on the call who remember me, and even those who don't, I just want to say a big thank you. Really, we are the product of our parents and you. After a while, you realize that there's really nothing particularly special about us as kids. We just, you know, we have to happen to be in the right environment. So thanks to you, hope all is well at the NES. For the students on the call, I know it's a difficult time with COVID. It's probably a very different world to the one I was in. Big tip, you've got a lot of free time now and a lot of great resources online. So really try to invest in that time, learn some new skills, try new things online. It's a really, you'll look back at the time you've got now and be amazed at how much free time you've got. So it's a very important asset. And I wish you all the best in your futures. So look, the title of the talk is Aviation, but we only have 5 minutes. I'm very likely to go over, but I didn't want to spend this time talking in general about aerospace and aviation because I think you can find a lot of that online. Instead, because I was once one of you, I thought I would give you some practical experience and lessons that I learned specifically as a Jordanian NES graduate looking to study abroad, looking to study engineering abroad. And sort of give you advice that maybe is difficult to find from general sources and give you sort of first-hand experience of what I thought went well, what I thought maybe I would do differently had I knew what I knew today, and just some very kind of specific advice as well on preparing if you are looking to study abroad or thinking of studying outside of Jordan. So I'm not here to sell aerospace engineering to you. I'm just here to tell you what it offers, what sort of conditions could make it appropriate for you to consider as a career choice. And then, of course, these slides will be shared and my contact will be shared. So if you want to ask more specific questions later, we can do that. Okay, so 13 years ago. 13 years ago, I graduated. I got accepted to study engineering at the University of Cambridge, which was a huge privilege. Just really wonderful 4 years of my life, where I ended up specializing in aerodynamics and control systems, which ended up being called aerospace engineering. If I look back, so the first thing I really want you to think about as students is how important the environment is. Because look, Cambridge, of course, has a brilliant brand name, and it's a wonderful place, but it's not just the brand that makes it a good place to study, it's the environment that it offers. And that same environment is available in a lot of different universities around the UK, a lot of different universities around the world. So really think very carefully about the universities you're considering. If you look here on the left-hand side, we've got, a professor spending time with 2 or 3 students. These things are called tutorials or revision classes. And then on the bottom left, you can see, this beautiful green space, which is very important. If you want to live on campus, you'll have your time to go between lectures and visit colleagues and professors is short, so you have more time to study and do extracurricular stuff. It's very important to think about the campus life and the general facilities of the university, because on the right side, and I'm really picking on London here, so I hope no one gets offended, but there are some good universities in the big crowded cities. But a personal reflection of mine is you're going to spend a lot of time in these sort of crowded lecture halls, which isn't really good value for money if your parents are paying to send you abroad. And then you're going to spend a lot of time in these crowds on the bottom right, which means you're going to be stressed, you're going to be thinking about things. There's this kid in the green jacket, you see he's sort of holding his chin. Think about that. It's very important. I know we're not talking about aerospace yet, but this is quite important. And if I look back, I think that's one of the things that made my experience at Cambridge great. And if I compare myself with colleagues, I think that's one of the things they really that really impacted their experience is the environment in which you study, the ratio of students to teachers, and the amount of exposure and interaction you get with your students and your teachers. Okay, so you've decided to study abroad. You want to do something that's called engineering. So what is engineering? I mean, in layman terms, it's how we use maths, physics, and common sense to make our lives easier. Okay. And I think coming from Jordan, we're very well placed to study engineering around the world, because I think we have good, generally the NES has a very good maths and physics curriculum. It's very well taught. I remember my teachers very fondly. And I think from a theoretical side, we're quite good. But I think certainly as a Jordanian going to study in the UK, I found myself a little bit disadvantaged to people who've grown up in the UK or Germany or the US, because I think they have a much more practical curriculum, and generally the facilities are better in those countries. And also there are these sort of 3 soft skills, or they're not soft skills, they're 3 hard skills really that I've put on the screen that if I were to go back in time, I think would have been really good if I studied them outside of school or developed them separately, because I think they would really enhance your ability to get the most out of your degree and actually create things and make things when you're doing engineering, and not just be learning the theory. So the first is on the left, and I'm not sure where you've got to in the NES. I'm sure you've got some sort of programming, but try to learn a programming language. There are a lot of free tutorials these days that can get you into it softly, places like Codecademy and Udemy. And I'd recommend probably for scientific computing or engineering, thinking about Python or C++ or Java, because when you get to university, everything's very quick and you don't really have time. You're just ticking the boxes and trying to finish the course, rather than actually using the information, trying to make something. And I think if you've done some preparation, that'll really help you. The second is statistics, because I think statistics is really at the heart of a lot of interesting concepts in machine learning and in AI, artificial intelligence, and a lot of sort of optimization problems in engineering. And it's a deceptively simple thing when you look at it from the outside, but there's a lot of thinking behind it and thinking about how numbers are grouped that I would really recommend you think about. And the third thing here on the right is drawing. It may sound funny, but this is industrial design and perspective drawing you've got here on the right. And people don't get excited about engineering or numbers. Okay, people get excited about things they can see and drawings. And if you're able to communicate what's in your mind visually, even if it's simple, it's an important skill to learn. And you can learn it on your own. Again, if you turn up at university and you have to learn this from scratch at university, whilst you're learning 10 other things, it may be a challenge. So if you can invest any time in trying to learn one of these 3 things before you go to university, you've got a really good head start, especially if you want to study engineering. Okay, so you're at engineering school now, you're in your first year or two. Most engineering degrees in the UK are between 4 and 5 years. And they pretty much all, as Professor Martin said, in the first 2 years, teach you a general curriculum. And that general information is very important. And I would actually suggest that you try not to specialize or try not to even decide what your speciality is before you go to university and actually learn things and explore things for a year or two, because you typically only specialize in the last year or two. And so before you do that, it's really important to think about the skills you're learning, the transferable skills, because those skills are very applicable in places like technology. They're applicable in places like finance and general analysis across consulting. And there's a lot of degrees where they value your ability to think like an engineer. Okay, and also really try to get some internships if you can in sectors that you may not have considered before, like energy or automotive or manufacturing, or even construction or medical. So really try not to specialize too early and explore your options. Again, if I look back, there were things I didn't know that I didn't know. So if you try to say, okay, in the next 5 years, I want to study aerospace engineering, but you don't actually go through the first 2 or 3 general years, you've missed out a lot. And I think it's really worth keeping an open mind. Okay. So anyways, that's the general overview. But I think these 3 things are things I would tell myself when I was 17. So I really do hope they're useful to you. But now going back to the title of today, which is aerospace, I'll talk about specifically about my take on aerospace engineering, what it is, what's different about it to general engineering, and what sort of things you can learn and design and do. Okay, so the first thing is it's not the easiest branch of engineering. The type of mathematics involved towards the end when it comes to fluid dynamics and aerodynamics and also thermodynamics are fairly complex. We also do a lot more, I guess, simulation and linear algebra than things like civil engineering. So first thing is really think about, do you like maths and are you comfortable with maths? Because I think it's a pretty important part to the speciality towards the end. So, but once you've got over that, it's really rewarding and really fun. So I'm just going to go through kind of these 4 or 5 pictures to give you an idea of what sort of things you'll be able to understand as an aerospace engineer and what sort of things you'll be able to design. Okay, so the top left here, you see this really cool hummingbird. It's beating its wings at 60 times a second. That's really slowed down. And if you notice, it doesn't have an engine. It doesn't have a propeller. It doesn't look like the airplanes we know, but it's staying, it's staying in the air and it's just floating there. Look at how still its head is. So when you study aerospace engineering, you will actually understand mathematically why that's happening, how it's staying in the air, how it's able to keep its head so still. And those are very interesting parts of analysis, and they're applicable to a lot of different other machines and devices and robots. So you'll be able to study that sort of thing. And then in the middle here, in the top, aerospace and aviation, aerospace isn't just about airplanes, okay? It's about things that move in the sky, in the atmosphere, in 3D. So these wind turbines that you can see, they all have these very big blades. You'll be able to understand, how they can be made more efficient, how they're designed, how they're built. And then in the top right, you see this little flying car. And that's quite interesting because aerospace today is a very different field to what it was maybe 15 years ago. You probably know the big Airbus and Boeing airplanes that you ride on if you want to travel abroad. But there's a whole new field of aerospace engineering that's looking at sort of micro air vehicles, drones, flying cars, if you will, electric air vehicles and hydrogen powered aircraft. So there's a whole new generation of architecture of aircraft that we're likely to see in the next 10 or 20 years that you could be involved in. And then just look personal perspectives. At the bottom right, you can see there's a picture of me. It's a drone I built myself. So, I mean, the skills you get yourself, you can apply in your day-to-day life and your hobbies. And, I don't think I would have been able to build that drone if I didn't start aerospace engineering. And then finally, it's a very global field. So aircraft are everywhere, airports are everywhere, and airplanes are actually manufactured in 10 or 15 countries at a time and put together. So if you like a career where you can travel and interact with different countries and different cultures, aerospace is a very good choice. So I'm not going to run through this table on the call, Kareem, because I think it's too much text. But what I did here is I listed what are the places you could potentially work, what are the areas and segments you could potentially work, and what are the key employers in each of those sections. I think it's very important, if you are interested, to look at this presentation after, and I'll share it, to really have a think about what it is you want to do in aviation, because you could be involved in engineering, designing aircraft, manufacturing aircraft, modifying aircraft, but even operating aircraft, so airlines, and even leasing and trading aircraft, so finance. Or you can get involved in research, so optimizing new aerospace technologies, or you can get involved in general manufacturing or with the trade bodies. So there's a lot of different types of aerospace and aviation jobs. But the most important thing to remember, and this is something I'll focus on again in the next slide, is have a think about where you think you'll live in the future. Because being very honest, aircraft are only manufactured in about 2 or 3 countries in the world, and they're only designed in 2 or 3 countries. So unless you really think you and your family and from your personal perspective, you want to move to the UK, or you want to move to the USA, or you want to move to Germany or France, it'll be quite difficult to get a job in aerospace, especially in engineering or manufacturing. You're more likely to be able to get a job if you want to go back to Jordan or the UAE or the Middle East in airlines and operations and maintenance. Okay, so have a careful think about that, because just to set your expectations, if you want to actually work in aerospace, manufacturing and design, you probably want to do that in a different country. And that may be something you might not want to do, or your parents might not want to do. Okay.
Should we move on to questions, please?
Excuse me?
Should we move on to questions, please? Because we have another session after this.
Kareem, let me just finish. I have just 2 more things I want to say, and then we can open up for some questions, okay? I just wanted to sort of finish this presentation by saying, if I look back to when I was 17 or 18, I was asking, what are the things that I enjoy? What do I want to study that will be fun? But I think it's also probably more important to think about, what does the world need, okay? And what are the jobs that are in demand? And what are the industries that are growing? Because if you choose something that is fun and excites you and is interesting, it may satisfy your curiosity, but it may be difficult to find a good job in it, for example, in Jordan. Okay, so have a careful think about, what does the world need? What does the Middle East and Jordan need? Think about things like renewable energy. Think about problems that you see around you, and then try to work backwards to think about what are the skills that you could bring to it. Because I think the most important thing to having a good job or starting a company, or even having a fulfilling career in research, is to be working on problems that are relevant and where you can be useful to others, because that's where you're going to be fulfilled. And the most important thing is to be fulfilled. If you're fulfilled, you're happy, okay? And everything else follows from that. Sorry, Kareem, that I went over. I think I'm ready for questions, if that's okay.
That's fine. Thank you so much for your presentation. I have a question from Mr. Hendry, Professor Hendry. Is there a career in physics outside of research and university?
I missed the first 2 words of that, Kareem. There was an echo. Could you say again?
Yeah, Mr. Omar, can you please mute your mic? Thank you. Is there a career for physics outside of research and university?
Yes, absolutely. I'm sorry I didn't have time to go into the details of that, but the web links in the final or the second last slide I showed list a huge variety of different careers. Essentially in finance and actually in engineering. Many people working in engineering began in physics, or in education, to give 3 examples.
Okay, thank you. We have another question for Omar. What was the best piece of advice you have gotten from either a teacher, a professor, or just a fellow student that has helped you the most in your working life and university?
That's a good question. Probably the thing I said at the end. and it wasn't advice from a teacher, it was more advice from the first few bosses I had, so people in the actual industry. It's to not think too much about what you want. Think about what you can offer. Because if you think about what other people want, you'll be happier and more useful than if you just think about what you want for yourself. I hope that's useful advice.
Yes, thank you. I believe that's all the time we have. Thank you, Professor Martin and Mr. Omar, for being with us today. Really enjoyed your talk.
No problem. Thanks, everyone. Bye-bye. Good luck.
I'd just like to say thank you very much for your time. We appreciate it, and the wise words there, wise word, wisdom. Thank you so much.
Bye-bye.
Bye-bye.